I wonder why there's not more. You've let people in, right?
Yep, I'm letting people in as they trickle in. And I'll continue to do so as you do your intro slides as well, Jay.
Okay, great. Yeah, we can wait to see because I've got it on my slideshow format. I see just the five of us and my slide that is there. So I didn't realize you've got a bunch of people that are already there. They're seeing each other. I just don't see them yet.
If you hit participants, Jay, you can see who's in.
I don't have access to the participants. That's not important though. Oh wait,
It's down at the bottom. It's down at the bottom. It's the bottom on the bottom bar. You should see it.
I would, but it's yeah, I'm not going to worry about it for now.
Okay.
But it's because it's got I've got both my screens have the PowerPoint on it. One is my speaker view.
Great.
Let us know, Ian, when you think we've got when it's time to begin.
Yeah, whenever you're ready. We've got 16 folks on the call, so I'll keep admitting as they trickle in.
There's Bronwyn. Hi, Bronwyn.
Glad to have you here. Well, let's go ahead and welcome those of you who are who have already arrived and the others who will be coming on in. I'm Jay Gentry. I'm with Passive House California. We're co-sponsoring this event with 3C REN. And the whole idea is to integrate Passive House standards with CALGreen for multifamily buildings across the different climate zones. And the reason this is such an important webinar, in my view, is because a lot of times the reason or the hurdle or the barrier to getting the first passive house or the passive house buildings in multifamily are because of the milder weather that we have. It's more difficult to make the cost to make it pencil out as you're looking through. So that's what we're doing. So just so that people so that you all know. We are Passive House California, and if you want to go to the website, it's passivehousecal.org. We are a part of the Passive House Network, the U.S. National. We are also a part of International Passive House and the Passive House Institute that goes from there. I want to first thank 3C REN for co-sponsoring this with us. It's a Passive House driven webinar, but we really appreciate 3C REN being a part of it, and I think we hopefully will continue this relationship as we go forward. So thank you to 3C REN, and then thank you to Southern California Edison, our gold sponsors, to Small Planet Supply, Minutair, and Rockwool, who are silver sponsors. And we have a number of supporting sponsors that you can see there. I can let you look through them, and rather than try to read them all quickly, I'll give you another 15 seconds to look through and see who all is there. And thank you to all of those organizations. And then I will just momentarily here, I'm going to turn the screen over, unshare my screen and turn it over to Beth Eckenrode. It's Beth and Craig and Matt are all here from Oros Group, and we'll turn it over to them at this point.
Great. Thanks, Jay. And let me share my screen. Uh-oh. Let me try this. There we go. It's asking me to, let me do this. So much for our practice session.
If it goes wrong, it's always my fault.
Okay. So now the question is, can you see the slideshow?
Yes.
Okay, perfect. Sorry, everybody. So just a few slides first before we get into kind of the meat of the discussion, which is really to answer one question, and that is why not? Why not passive house? And we've done some work that we want to share with you. And really, most importantly, we want you to feel like this is an environment of people all trying to do the same thing. We are all mission aligned. So where you have a question, where you have a fear, where you have a difference of opinion, this is the environment in which we should be sharing all of that, because there are no sacred cows here in this environment. The Oros group, we look through a certain lens. And we look through the lens of building science and data science. And it's important to know that, because we use tools that inform decisions in a way that I think reduces risk. It increases the likelihood of performance. And we do that because we believe that by combining building science and data science is about the only way to get to zero anything. Doesn't matter which form of zero you're talking about, zero anything in the most cost-effective way. And so we look through that specific lens. When we talk about our approach, we change the process. So we've kind of revamped this notion of owner's project requirements to be about metrics. So what you see here on this slide is essentially what an owner's project requirements looks like with the Oros group. It's a 9.5 by 11 sheet of paper. It's bigger, 11 by 17 actually in some cases, 11 by 17, and it will have maybe 50 or 60 metrics that we hold ourselves and our teams accountable to. And then we open source all of our tools. So there's nothing that we do that we don't share openly. And that's because we think that it's important to get to one version of the truth. Everybody sees the same inputs. Everybody has the opportunity to play with the same variables. That process, this piece right here, is what fundamentally changes the conversation of how to get the most out of passive house. So you'll hear me say a few times during the next hour, we try to wring out every piece of energy consumption we can wring out. It's like taking a towel that you think you've wrung dry, but you really haven't. There's still more. There's still more to get. And everything that we can get out benefits every other decision we make. So that's how we approach this entire conversation. And we talk about iterative evidence and iterative tools. We use through conceptual into schematic into design development. We are taking detailed energy models and we're combining that with unit control cost estimates. So at the unit level, in a detailed way, not by square foot, in a very detailed way, we do iterations of this in order to make sure that nothing gets away from us. We have control of all the different levers. So at any point in time, we can answer for an owner, did you get what you paid for, with 3 pieces of information. 1, what does a decision impact in terms of performance? How does a decision impact long-term operating costs? And how does a decision impact first costs? For the purpose of this discussion, probably one of the most important things to talk about is the fact that we have a very unique approach to how we think about existing buildings. And that is that the very, very first thing we do on every project is determine the optimum decarbonization potential of a building. So instead of starting where most people start, which is what can we incrementally do to get better, we take a building and we figure out what it's capable of achieving. And then once we know what it's capable of achieving, we start trading up. So as I'm sure you can imagine, it's looking through the prism in a different way, right? So it changes the way you think about making trade-off decisions. And then we do the continuous modeling and continuous estimating that I was talking about earlier, because it reduces risk, it reduces technology risk, it reduces financial risk, it reduces performance risk. And we do that consciously on every project. And we believe fundamentally that you do not have to spend $1 more to get a high-performing building. And the thing we say is brick doesn't know it's in a passive house, and drywall doesn't know it's in a passive house. So there are things that we trade off by doing the passive house building science, by following this passive house standard. We understand how to get the most out of a building, and it shouldn't cost $1 more to do so. We start with foundational elements. In our world, that's passive house and reset air. Why? Because it's the same building science that gets you to not only low energy, but really healthy and world-class indoor air quality. And that's what we get out of the reset air standard. In your world, well, we'll talk about foundation as we'll talk about CALGreen, and Matt will get into that a little bit more. as he starts talking about some of our analysis. But your foundation pretty much always starts with CALGreen. In our world, I just bring that up because if you don't know about Reset Air, it's the same building science. The 5 principles of Passive House apply to indoor air quality, and you get kind of a double bang for your buck. So we'll talk a little bit more about that as we go. So Matt, I'll turn it over to you.
Yeah, sure. Thanks a lot, Beth. Okay, so what we did for this presentation is we took a building that was a multifamily building that was pre-certified for the Passive House standard, and applied it across 4 different climate zones in California. So we started with Sacramento and went to San Jose and went to Los Angeles and went to San Diego, and just wanted to see a baseline of how the building performs with code levels of insulation, right, compared to the Passive House standard. And let's see what it's going to take for us to take this building from Title 24 all the way to Passive House certification. And so what we ended up finding here, and so we're going to take a look at the results first, and then we'll kind of get into what the inputs were. Okay. So looking at this graph, we've got 2 metrics. 2 of the 4 Passive House certification metrics are heating demand and cooling demand. And those are strictly envelope-based metrics. It has nothing to do with heating and cooling system efficiencies. It's strictly what the building is going to demand over the course of a year. And when we looked in San Diego, we'll start in San Diego and we'll get colder as we go through the process. Just building to Title 24, we're going to see our heating demand is below the Passive House limit. So this line right here, this black line that I'm turning to a red line, is our Passive House limit of 4.75 kBTU per square foot per year. And what we can see is right off of the bat, San Diego kind of checks the box, right? It's meeting heating demand and meeting cooling demand. Now, when we apply some of the other mandatory requirements that Passive House has, such as air tightness and whole building heat recovery ventilation, we can further drop those values within San Diego's climate, right? And so when we take a look at the same situation for Los Angeles's cooling demand is above the limit when we build the building to Title 24 limits. Okay, when we apply those Passive House metrics, the required Passive House metrics, to the building, we are dropping it into the certification level for Passive House criteria. Now, as a side note, cooling demand does increase a little bit above 4.75. It's based on the dehumidification requirements. But for the purposes of this presentation, we're just going to say it's 4.75. And we are certainly under 4.75 for our cooling demand in Los Angeles. Okay, we moved to San Jose, a heating dominated climate. We can certainly see that San Jose, its heating demand when we build to Title 24 is still above the Passive House requirement limit of 4.75. So when we apply Passive House criteria to our building in San Jose, we can very easily bring it well below the requirement of 4.75, both for heating and cooling demand. Okay, and what we'll see is as we insulate these buildings a little bit more, we're extending the cooling season a little bit. So we're going to see a slight increase in cooling demand between a code built building and a Passive House building, but still well below the requirements for certification. And then when we take a look at Sacramento, Sacramento also is not achieving its Passive House criteria. But when we apply Passive House principles, air tightness, heat recovery, ventilation, we can certainly achieve Passive House certification just by applying a few simple things. Okay. And so on the next slide here, what we're going to see is source EUI. And I want to make sure that we understand the difference between source EUI and site EUI. When we start talking about this net zero energy philosophy, source EUI becomes really, really important. Okay. And I'm going to dive into that on the next slide. But over here, what we're going to see is currently built to code using some other assumptions for this building. We're already meeting the passive house requirement of 38.1 kBTU per square foot per year. All right. So by applying those principles to lower our heating and cooling demand, we're also lowering our source EUI. Okay. And so we're going to see that effect happen for all of these buildings and in all of these climate zones, right? We're going to see just by really altering our heating and cooling demand, we're going to see the source EUI change. And you might say, well, what does that matter if we're already meeting our source EUI number, right? Why are we worried about lowering it that much further beyond what's required for certification? And on the next slide, we're going to take a look a little bit at the path to net zero. And I should have said the path to net zero energy on the graph, right? So this is path to net zero energy. Now this graph is gives you the percentage of roof area required to be covered in PV panels in order for the building to be net zero. And when I say net zero energy, I'm talking about site net zero. So the amount of energy turns out to be around zero over the course of a year. Okay. And when we start talking into that philosophy, well, first of all, the roof area, we can never use 100% of the roof area for PV panels on a multifamily building, right? It's not feasible. We have rooftop mechanical equipment. We've got all kinds of other things going on. The roof is usually not just one roof. Usually there's 2 or 3 different roofs. And so it's not practical to say, yeah, we can fit it on the roof, but we have to use the whole roof. So any little bit that we can squeeze out is going to yield more room on the roof for things like mechanicals and roof drains and all of the other stuff that happens on a roof. Okay, so San Diego, we were able to reduce the amount of required area by looks like 5%, right? And so each one of these is much easier to achieve net zero. So we're using fewer panels. We have the ability now to not have to cover the entire roof with PV panels, but that's not preventing us from doing so. But that just means that it's so much easier for us to do it, and it's less cost, right? We don't need to cover the entire roof with panels. Why should we? Now, one other metric that I would want to mention here is when we talk about net zero on a building, sometimes that's not even possible, right? If we were to get into a 16-story building that's really tall and really small, a small footprint, the roof is never going to be able to hold enough PV for that building. And why should we penalize a building for having really good form factor because it can't fit enough panels on the roof? So that in and of itself means is really net zero energy the target here. And on the next slide here, what we're going to see is, you got that, Beth?
Yep.
Okay, there it is. So now this is for a single family house. Okay, but bear with me here. The graphic is still going to be the same thing. We've got 2 things that we're showing on this graph here. We're showing electrical PV production. Okay, so PV production here is this yellow line, and I'll follow it here with yellow. So during the summer months, we're going to create more electricity, right? And so it's going to be a bell curve. Okay. And then what's going to end up happening when it comes to energy demand, the building is not going to require energy when we can make it, right? The sun is going to set. The winters are going to be long. The days are shorter. We just don't have the available solar energy out there in the winter. Okay. And when we're using electricity is usually during the winter, right? For heating, for water heating, all of those other things. So we end up with this big gap in these shoulder seasons. And when we start looking at a fully renewable grid, the gap that we're seeing is going to have to lead to long-term energy storage. Okay. And long-term energy storage is going to be much, much less efficient than short-term storage, right? Batteries are a good idea, good example of short-term storage. But when we're talking about storing energy over the course of a year, large amounts of energy, that is going to be extremely inefficient. So what we need to target is our source EUI, not our site EUI, our source EUI. And when we target that, that's going to reduce this gap by applying passive house principles to a building. And we'll see that on the next slide, right? So that gap is gone, but not gone, but it is severely decreased. Okay. And so what this is going to do is it's going to give us a much more clear path to this long-term storage idea for our grid to become totally renewable. And like I said, in the percent of PV required to be on the roof, now when our buildings are much more energy efficient, we don't need to create all of this extra energy with all of these panels. And so on the last slide here, we'll see we don't need as much solar on the roof. The gap is still relatively small. We're still net zero, but we're saving ourselves a little bit from a more intense long-term storage option for our grid. So what we ended up doing, now we're going to talk a little bit about the building itself. So our workflows generally start with some sort of SketchUp model or some sort of 3D model. And what we can do is we apply the principles and all of the different material properties to it. So we'll start with our geometry. We're going to assign the properties, right? We're going to assign thermal properties, our R values, our U values. We're going to draw our treated floor area, right? And so now we can start having all of the basis for our energy model. And then we're going to take that SketchUp model, right? So here's our SketchUp model right here. And we're going to build the geometries. Okay. We're going to show any other shading elements. So we've got a neighboring house over here. We've got a tree with some leaves over here. We're going to set the orientation of the building. We're going to add any balconies or other shading elements to some of these windows, right? And once we apply all of these factors, now we can simulate the energy model. And so what we're going to do is we're going to take each one of these windows, right? And we're going to analyze it for its shading. Okay. And so what we're seeing over here is this little grayed out area is the effect of this tree. Okay. And so each one of these windows is going to get analyzed in a similar way. And then we're going to take all of that information and we're going to export it to our passive house planning package spreadsheet. Okay. And once we get into the spreadsheet here, we can really go to town in terms of further analyzing different things. This is where we're going to end up modeling our ventilation systems and things like that. So the building that we used for this analysis was a 49 unit multifamily building. It was roughly 43,000 gross square feet, 38,000 treated floor area. The building was all electric. Okay. It had a centralized heating and cooling system with using VRF with air source heat pumps. Okay. The domestic hot water system was an air source heat pump with a domestic hot water circulation loop. Okay. And one of the things that really benefited this analysis in terms of meeting passive house criteria without really changing a lot is the shape. Okay, this building has extremely good form factor. Okay, and as passive house designers, when we start designing buildings, this is the first place that we go. This is the easiest button to push. Let's make it a simple shape, because when we make it a simple shape, we need less insulation. Okay. And what this graph here is showing is the worse the shape gets, the more insulation we need, right? When our buildings look like a cross, we're going to need 17 inches of insulation. Whereas if it was just a simpler shape, we might only need 4 inches of insulation. So that the fact that this building was basically able to meet passive house criteria right off of the bat using using Title 24 minimums really has to do with the form factor. Okay. So what we did was we took all of our R values right from Title 24, right? So you don't need to look at these numbers, right? But we've got climate zone 4, 7, 9, 12, and then this is what we use for our ceiling insulation for our energy model, right? So we just took all of the numbers right off of Title 24's document. Right, our wall R values came right from Title 24, our mass floors and our slab perimeter insulation, if there was any required, our window U values. And what we went with was the maximum U value, right? Like this is the worst window, and chances are the windows that everybody on this call is using are going to be slightly better than the worst windows anyway, because if they're right on the borderline, you're probably not going to sell too many windows. So the windows that we used in the energy model were the maximums required by Title 24. And so once we apply all of these things, and now we apply our mechanical systems. So we've got balanced ventilation systems required, maybe not with heat recovery, but some sort of ventilation system is required per code, and the duct insulation is required per Title 24. So we applied all of this information to generate our code-based models. Okay. And what we found was, and we'll start with San Jose and work our way to Sacramento. What we needed to do in San Jose was slightly improve the window U values, right? Passive house windows are somewhere in the U 0.16, 0.17 range. We only needed to go down to a 0.28, which is still a double pane window. Okay. Solar heat gain coefficient of the glass or of the window was 0.23. We defaulted to 75% heat recovery, which is a passive house minimum. We could probably get away with a little bit worse, but for the purposes of this presentation, we just wanted to go with minimum requirement for product certification. And we're building a tighter building, right? Air tightness. That's it. Heat recovery, air tightness, and slightly better windows drop us into certification criteria. When we look in San Diego, all we needed to apply was heat recovery, the other requirements for passive house, right? Heat recovery, ventilation, and air tightness. Okay. Again, easy buttons. We didn't change any insulation anywhere. In Los Angeles, a slightly better U value, right? A 0.31 U value. We had to apply exterior shading devices. Exterior shading devices are much more effective at keeping that solar energy out. They're about 80 to 90% effective compared to interior shades, which are only about 10% effective. Okay, so we added exterior shading devices, again, heat recovery, ventilation, and air tightness, right? So check those boxes. Within Sacramento, we had to improve the U value still to a really good double pane window, a U 0.27 with a solar heat gain of 0.23. Slightly better heat recovery. I mean, there's certainly a give and take that we can have here. We can maybe go to a triple pane window if that means lowering the heat recovery. But we went up to an 80% heat recovery system, and we're still at 0.6 air changes per hour. Again, the passive house minimum requirement. Okay, so not super levels of performance better, but meeting the passive house criteria nonetheless. And so in summary, what we kind of concluded here is in the 4 climate zones that we tested, passive house does certainly give you that much, squeezes out a little bit extra energy efficiency, right? And energy efficiency is not going to change over the course of the building life, right? Mechanical systems are going to fail. You're going to have to replace them. But the envelope of the building really isn't going to change very much. Renewables, right? When we apply passive house principles, we need less renewables. Or when we get into some situations, you can fit it on the roof and make the building a net zero building. And then we also apply some of the other things that people like to talk about with passive house, right? When we apply balanced ventilation with heat recovery, we have better indoor air quality. We have way better odor control. When we also apply the air tightness to the building, air tightness and ventilation together really is what allows the odor control to be best. And passive house is essentially a comfort standard that achieves comfort through energy efficiency. So we also get that extra occupant comfort out of it. And then the primary reason we build airtight isn't for energy savings, it's for long-term building durability. Okay. And so our buildings are going to last longer when we build to the passive house standard. And airtightness shouldn't cost more. Airtightness is craftsmanship. Okay. And if we can apply passive house principles to all buildings, they should all be more airtight. Okay. That shouldn't cost any more money. The systems are going to work better. Balanced ventilation systems are going to be much easier to commission when the building is tight, because now we don't have the leaks that are happening all over the place, okay, that are throwing off the ventilation system. We're going to have more consistent temperatures, and we're also going to dramatically improve the acoustics, right? Noise transfer from room to room, from outside to inside. All of those things are going to fix themselves with airtightness. So that's all I've got here. If we wanted to turn it over to,
Yeah, I'm gonna stop sharing and let Kyle get
Sure.
Kyle Crete from Wildan get himself set up. But Matt, while we're transitioning over,
yeah,
could you maybe explain a little bit? PHI is talking more about PER as a metric today. Could you maybe explain that now that you've gone through this analysis? What
Sure.
does that mean in layperson terms? Like, how should we think about that?
Yeah, so primary energy renewable is a metric that is applied to, so generally speaking, source EUI has a default value. It's around 2.6 for primary energy values, right? So we're assuming the grid is 2.6 times less efficient than site EUI, electricity generated on site. So primary energy renewable is another way for us to not penalize buildings, because it's going to be amount of our total energy demand divided by the usable roof area, not our floor area. So when we get into some situations for buildings with really, really good form factor, we can still meet the primary energy renewables targets by adding whatever we can kind of fit on the roof, and we're not penalized for having really good form factor and not being able to fit enough PV on the roof. Okay. There are also some other aspects to primary energy renewables that go into a more futuristic grid that's 100% renewables, and each climate zone is going to have its own targets. So the grid might be cleaner in San Jose than it is in Los Angeles, and so we're going to account for what a futuristic grid might look like compared to just using a blanket primary energy value that's used throughout the country.
That's great. So Kyle, let us flip over to you, and then when we're done, we'll come back and go into the Q&A.
That sounds great. Hi, everybody. My name is Kyle Crete. I am a program manager at Wildan, and I work on the California Energy Design Assistance Program, which is CEDA, as well as our PG&E government and K through 12 program. Hold on. There we go. Okay. So our program, CEDA, the California Energy Design Assistance Program, started out as a traditional energy efficiency incentive program. So we're the statewide program for new construction, but as our program has evolved, we've shifted much more into like the electrification of buildings and decarbonization. And I forget how we got connected originally with Passive House, but through many, conversations, we got connected with the Passive House crew. And what's interesting is that since we work so closely with PG&E and their codes readiness team, the work that we're trying to do to promote the adoption of, electrification and decarbonization, it aligns so closely with Passive House that, we started working with them, and the work we're doing together is going to be used to evolve the future energy code cycles. So that's what we do in a nutshell. So we work with project teams to help them reduce energy demand, consumption and carbon emissions. So to, why would you want to, work with our program? Ultimately, like, we do offer incentives for efficiency measures or high performance measures, and I'll touch on the difference in those in a little bit. But also, as you're doing these analyses, we can help offset some of the cost, for your time, your design team's time, and as you get involved in that. So our program, we try to make it as low commitment as possible, couple meetings, and we can do your energy model for you, or if you do it your own, you can get the design team stipend for that as well. And then we want to demonstrate the commitment to high performance buildings, and building practice and design. So we're all in this together, and it takes a village to get the the grid and California where it needs to be. So if you're working on one of these projects, going after passive house, and you want to maybe offset some of the costs or see what other opportunities are out there. So we do offer as I mentioned, design team incentives, which starts at $2,800. So ultimately it's to, offset some of the time to participate in meetings, and, this would go to the design team or the owner, and they can distribute it however. But then you have your traditional energy efficiency measures, your high performance measures, all of these things that come together for decarbonizations. So that's like your second portion of the financing, well, it's not financing, it's an incentive, right? So that's the second portion. And then the last portion is if you want to do it yourself, we want to encourage, passive house modeling to take place. So if you do all the modeling yourself, or your design team puts it together and go forth and submit the documentation, we help a little bit with the submission on the end. So you would submit your modeling to us, and we would upload it, to the CPUC and all that good stuff. You would be eligible for that, $5,225 as well. So right off the bat, is that like $8,025, just to do the modeling, and then you would have all your additional incentives as well for energy efficiency measures. So what are some of the high performance measures that we like to see that are out there? So things such as heat pump water heaters and central heat pump water distribution loads are very popular. If you're looking at air conditioning systems with low GWP refrigerants, that's one of those newer incentives that's out there. Typically doesn't fall into the energy efficiency aspect, but it's all in the promotion of decarbonizing the grid and buildings as well. The Oros group has been very helpful in developing some of the high performance, the building envelope measures, and they're not listed on here. I guess they don't really, fall into one of these categories, but maybe I need to update my slides at some point. So increased insulation and thermal bridging, and a lot of those passive house strategies fall into here. So this is an opportunity to not only design the building well, but then, get rewarded for it, from the CPUC as a thank you, essentially. So how do we go about calculating our incentives? Well, you have the participation, bonuses and whatnot. And so we have our discovery meetings, which is just tell us about your project, and we could go about and put together some of the modeling for you as well. And then as I mentioned, the incentive, we go through and we calculate what the actual incentives, the final incentives would be, based off of whether it be energy savings, or how much low GWP refrigerant you have, or what's the specific design. So that's we try to make it as painless as possible for the process. but as long as, you know, the main goal is to be more efficient than code, and we want to try and help PG&E and the codes and standards divisions, you know, to push California even further in the future. Hopefully not too quickly. That's a personal thing, but yeah. So the inducement process, you know, you commit to implementation. We ask that you share some of the design information. Pretty standard, as you know, if you've been through any of the previous energy efficiency programs, you'd share some information with us. You go through and install the equipment. We'll do some verification. There might be a little data sharing requested, but it's typically things, you know, like run hours or how much energy is being used. You know, a little more granular than like what you could get out of your whole building meter. But not every project will be, you know, selected for that information. And then once we verify that it's in there, we're free to, you know, cut the check, and you would receive the incentive, or the owner would receive the incentive. So try to make it as straightforward as possible. And if you have any questions, I think I'm going to hand it back over now to Beth, and I'll be here if you have any questions for me as well.
Great, thanks, Kyle.
Actually-
Yeah, go ahead, Jay.
Actually, we're handing it over to Jay at this point for just a couple of slides. And I see that we've got, thank you very much, Craig, for offering in the chat to keep track of the things that are there. I will note that I just put something in the chat that I'll refer to in a short bit. But looking, oh, here, let me get it up to the full slide. Thank you, Wildan, by the way, for being here and being a part of this, and for helping and sharing the information about the CETA program. I'll note here that there are many other multifamily passive, if you're building a high performance or passive house multifamily programs that might be of potential interest. There are loans available. The build program, if you're not building a 4-story or more building, which is required for the CETA program, and for affordable multifamily at least. The energy smart homes is for the smaller, as I say. There's a multifamily energy savings program you can look at. There are others involved. There's a couple of regional ones here in Sacramento and Southern California. And the Inflation Reduction Act, and this is a quote from something that I'm going to show you in a moment, but the landmark rate, it contains $4.5 billion in rebates that will reduce the cost of building affordable all-electric multifamily passive house buildings, as well as tax credits that can be worth as much as $5,000 a unit. So those are good things potentially to go forward with. And onto this next slide, I put 2 links in the chat. One is to the California Multifamily Resources, and it provides all of the things that I just listed on the previous slide. It has those plus more with links to them, where you can go and learn about the subsidies and things that are potentially available. And so you'll have access to that document just by clicking on the link that's in the chat. The other link I put in the chat, we were looking here at a single building that was a building that is going up on the East Coast. It's pre-certified, and taking that building and putting it in San Jose or Los Angeles or San Diego, and then what would that do if we did that to CALGreen, and then what would we need to do to bump it all the way up to Passive House? And that's, thank you for the presentations that have been there. That Safe at Home document, the Safe at Home document looks at a large number of affordable multifamily homes, multifamily buildings, again, looking at performance and things, so you can get a much broader look at how all electric multifamily passive buildings deliver comfortable, cost-effective climate resilience. And finally, we've got you. I put it in the chat, so we'll probably include it in the things that go out with that. 2 or 3 things that came up in my mind. I mentioned the first buildings, the Safe at Home I've mentioned. The the PHPP, the Passive House Planning Package document that slipped up when Matt was they talked about. That's one of the things that's very effective about Passive House is that while CALGreen, if you were putting together a football team, CALGreen has you'd get excellent players at every position because it's a broad program looking at the right thing. But what PHPP does is it gives you a playbook and an ability to do your game plans for particular buildings because it's performance related. And as one thing that Matt mentioned is we didn't meet this number, so do we want to add more insulation or go to a triple pane window? You're always looking as you go through the modeling to get to a specific performance result as opposed to just things that you do, prescriptive things that you do going forward. So I wanted to bring that up, and we talked about what it was doing in terms of energy efficiency and all. We didn't bring up what it does to the occupant experience. So the building what you get when you go to this level of efficiency and in particular the air tightness is you get the much greater energy efficiency, but much better indoor air quality and resilience to smoke. I saw Brahman put in the chat a smoke we call the building smoke tight. The smoke and they're more difficult to catch on fire and perform much better during power outages, or to give you a break back during power outages. So you're not only dealing with the mitigation of climate change by reducing the greenhouse gases, you're dealing with the adaptation of climate change because where we're living is more comfortable, more healthy. Pushes back against climate change in the way that we would like for it to do. And so what last thing here on the slide is in a few weeks, we're going to be doing a follow-up webinar to this because many of you, if you're a multifamily developers, you have portfolios of older buildings. And as Beth said, the idea of optimizing or optimum decarbonization decisions gives you the ability to get your existing portfolio the best bang for the buck as you go forward on it. I will now turn it back to Beth for Q&A, for the final touchback and Q&A. And so, thank you.
Great, thanks, Jay. And then I will ask Kyle a question. Kyle, there's a question in here for you. Can a project team do passive house modeling even though the project is not getting passive house certified and still get the design team incentive?
Yes, for us, our program is separate, so you can still do the modeling and work with us and still receive that incentive. Yes.
Okay, great. Hopefully, Teresa, that answers your question. If not, you can drop something more. If you'd like to come in, if you'd like to come off mute and just come in, that's great too. And then Matt, there were a couple questions early. Let's flip over to you, just in case people aren't monitoring the chat. So if you could provide the answers. Tom White asked, are the EUI and net zero energy PV numbers only for heating and cooling?
Yeah, so I'm a trainer with PHN, so I tend to talk a lot with very little content to fill up the time, right? So forgive me with with my answer here. So the net zero PV numbers when we're talking about the whole building net zero are going to be including heating and cooling demand. It's going to be including the heating and cooling system efficiency. It's also going to be including domestic hot water and appliances, and common area lighting is a big one for multifamily buildings, right? All of those other elevator, right, energy use, all of those things are always going to be included when we're talking about total site EUI, as well as a path to net zero.
Great. And then there was another question. To what extent does passive house decrease heat pump size required and decrease duct sizing required?
Yeah, that's a really good question. So decreasing mechanical system size is usually a big, huge selling point for the smaller buildings. Because typically those systems are well oversized to begin with. And so just right sizing your system is going to decrease the size. But what we're kind of seeing in terms of heating and cooling system equipment size reduction is somewhere in the 25 to 35% range for a heating system and 10 to 30% for cooling. And those are just kind of out of the air numbers that I'm picking here. I would say for a smaller building, it's going to be more than it would be for a larger building. Typically when we get into the larger buildings, right, especially for cooling system sizes, occupancy and internal heat gains are usually going to dictate the cooling demand more so than insulation levels, right? Or if we can do things for getting your mechanical engineer to buy into reducing his cooling equipment system size for shading devices, right? So sometimes it's what your mechanical engineer is comfortable with. But what we like to do is we always like to do an equipment sizing reconciliation with the MEP, where we'll open up either our PHPP model or an IESVE model, and we'll sit down over a Zoom call with the MEP and go through all of our assumptions so that we can kind of land on, a closer value to make them more comfortable with reducing the equipment sizes. I hope that answers the question without going too far.
One more to you, Matt, and then I'm going to flip back to Kyle. So if we expect high exposure to smoke or other environmental pollution, is it wise to provide fresh air intake filters before it enters the energy recovery vent system?
100%. Yes. Usually when we're dealing with a smoky environment or a poor air quality environment, we could see 2 or 3 filters. So a lot of times there are like a bulk filter followed by a more fine filter, because the fine filters tend to be more expensive. So if we can replace a bulk filter, a MERV 8 or something like that first before and then have the MERV 13 last a little bit longer. I've seen all kinds of those strategies as well. So now just to step back real quick and mention one more thing on duct sizing. That was another one that had been asked. Duct sizing is probably going to be dictated by code levels of ventilation requirement. So if we're talking about outdoor air ventilation, those ducts are probably not going to get any smaller because we have to meet code. So now if we're talking about forced air heating and cooling systems, of course, if you reduce the size of that system, the ductwork sizes can be reduced as well.
Great. And then Kyle, there's a question. Can CETA outputs be used as inputs for sizing PV to offset tenant and common area modeled KWH usage?
Yeah, so typically what we'll do is we'd like our thought process is, let's start with your design and let's make it as energy efficient as possible, and then use that savings or understand how much we can cut out before going in and sizing the solar system, for example. So the short answer is yes. However, if there's like particular consumption values that you're trying to hit or you need to understand, then yeah, we'd want to work through that. But yeah, we can help reduce your energy consumption before sizing solar is what we like to do. And then I hope that answers your question, Tom. And then I see there's another question in there from Craig, and yeah, we use Energy Plus as our modeling engine, but as long as it's CPUC approved, typically eQuest would work as well. So we don't have a specific modeling software required.
Great. I'll leave time for any other questions. While we do that, I just want to thank Jay for putting this together. Jay is, if nothing but persistent. And if he had to wait for either me or Kyle and his team at Wildan to jump on this, he'd have been waiting a long time. He drove this very hard. And hopefully you found some really great key learnings out of this. And we're all here and available. We're all on LinkedIn. And I don't know, Craig, well, if you could, maybe you could just put our emails in the chat. I tried to go back to my presentation, but it was getting wonky again. So if you could just drop our emails in the chat, that'd be great. And you know, Jay talked about the next webinar on portfolios of buildings. If you're interested in a double click, we did write a book that was published a couple of years ago that just won an Environmental Book of the Year award from the Academy of Management. It's called The Power of Existing Buildings. If you just Google Power of Existing Buildings, you'll find our book, which really does a double click on everything you just heard here in terms of the approach to get to zero and how to make it most cost effective using building science and data science. And you'll get a little bit more depth on the data science piece. We didn't go into that here because we really stayed close on the building science stuff. But if you're looking for a double click and you can't wait until the next installment of The World According to Jay, then maybe that's a way to fill in the gap. Otherwise, Jay, I don't know if you have some last minute comments, but I think we've answered all the questions.
I'll go ahead and share my screen. I do have a couple of comments and things that are there coming up, and I will go here to get this up. And this was you saw this during Beth's presentation, but I like to seek here that California is among the leading states in the country in terms of our decarbonization, and decarbonization is the building blocks of decarbonization are to make the building as energy efficient as possible, to minimize the embodied carbon in what you're doing, then electrify everything, put in clean energy, and you get the zero carbon that you're looking for. It implies that these happen in this order, and that is true in terms of when you're building it and doing a thing. But the really important thing is up front, you need to decide what you're going to get in terms of your owner's project requirements or the owner's performance requirements in terms of efficiency, in terms of embodied carbon, in terms of whether or not you're going to go all electric and how you're going to do your clean energy. So these things are additive, but they're really all move forward to the beginning of the decision when you get your integrated project team to kind of look at it. And the things that we are doing, I think, are very important, and really appreciate. I have one more slide that I show, and then I'll back up. Whoop, how'd they get to that one? Oh, I see. It's an add-on. Basically, this, as I say, this is both mitigation and adaptation to go to this level of efficiency. It's for the people on the planet, and the question is not why would you go to Passive House or to this high performance. The question is why would you not? And so now I'll jump up to this. Here is the contact information for Passive House California and info@Passive House, as well as the contact information for 3C REN. Thanks to everyone for all of that. If there are any more questions, we can certainly take more. I can't see the chat from my screen anymore. So, but Beth, have any other questions come in?
No, just a lot of thank yous, which is awesome. No, thank you. Thanks for showing up today and making us part of your day.
Oh, thanks. And we will have a recording of this. And if you got did the AIA and ICC credit things come through, Ian?
They did. Yep.
That's one of the really thank you things for 3C REN. This is a great group with Oros and 3C REN and Wildan. It's just been terrific. So thank you all for what you do and for the difference that you make. Everybody can take the rest of the day off now.
Jay,
Thanks,
Jay, I'm just going to say that if you're okay with it, I'd like to steal that graphic of the equation you had on the screen just a second ago.
Oh, sure. You want me to put it back up?
I got it. Yeah, that's the one. I'm going to steal that one if you're okay with it.
Okay. Well, what I'll do is I'll have one. This is what it says this is for new buildings. For existing buildings, you put the box over the passive house and the embodied carbon, and you look for their optimum decarbonization decisions, because you can't always get to there economically or with reasonable, but you want to get as close as you can. And as Beth said, if you take an approach of what is possible, then back down, you get a much better result than when you say, this is our budget, we're going to do, let's do some windows and maybe we'll do this piecemeal, as opposed to all together with what is possible, is the best way to start.
Great.
I'd encourage you to read The Power of Existing Buildings. It's a very powerful book for both existing as well as new buildings. And again, just thank you to everyone, and stay safe. We got COVID's on the rise again, so put your masks on when you go outside. I have 7 personal people that I know that have gotten COVID in the last month.
Great. Thank you, everyone.
Have a good day.
Thanks.
Yep.
Bye.
See y'all.
Hey,